So we're going to jump around a little bit on this. I want to make sure I give you enough to refresh your memory, but if I'm going over stuff and you remember it, then we can skip over. A few things that we need to know with our systems of equations. When I am looking for a solution, so a system just means you have more than one equation. The solution is what makes both of them true. So we're looking for typically an ordered pair here that makes both of them true. Terminology, you will hear me say consistent and inconsistent. So if you don't want to write everything down on this slide, you don't have to, but at the very least, you need to know consistent has a solution, inconsistent is no solution. You looked at solving them by graphing, solving them by substitution, and solving by elimination. Graphing was great, but they had to have a nice intersection point, right, before you could really tell. If they met at 1/3, 1/7, you couldn't tell that from a graph. So I am not even really going to focus on the graphing. I just want to talk about substitution and elimination. So, in terms of the graphs, if it has a solution, that's a consistent system. That means when you graph it, you have two lines that meet somewhere. So that point where they meet is our solution. Inconsistent. How could I have two lines that never meet? Parallel lines. All right. Is it possible for two lines to cross twice? No. So we will talk about some nonlinear systems later on, but right now, today, we're just talking about linear. So when we're looking at lines, they can meet once or not at all. Do you remember ever talking about infinite solutions last year? How did that happen? How could I have a system if they're the same line, if you have two equations for the same line? All right. So let's say I asked you to solve this by substitution. In general, I'm not going to care how you solve them, but when it comes time for a test, I will probably have one or two that I say solve these two by substitution, solve these two by elimination, and then do the rest any way you want. Just enough that I can make sure you know both methods. How would I do this one by substitution? Okay. So you pick one equation and solve for one variable. So she said subtract y. So x is just 8 minus y. So then I sub that into the second equation. So I'm going to replace my x. So my x is 8 minus y. Minus y equals 4. Combine like terms. And y is 2. All right, once I have my y, how do I get my x? Substitute. You can put it back into one of the original, or honestly, this is probably the easiest place. We already know x is 8 minus y, and if y is 2, then x is 6. Final answer, how do we write it? Ordered pair. X comma y, 6 comma 2. All right, is this jogging your memory? We've seen it before. Okay, remember, you can always check these. 6 plus 2 is 8, 6 minus 2 is 4. So I know I've done it correctly. You guys think you can try one? Here's your problem. Solve for y in the first one. So y is 5 minus 2x. Sub that into the second one. So negative 4x plus 6 times 5 minus 2x is negative 2. Combine like terms. Subtract over my 30. And x is 2. Is that what you guys got? Plug that back in. Y is 5 minus 2 times 2. So 5 minus 4 is 1. So my answer is 2, 1. And I can check it. 4 plus 1 is 5. Negative 8 plus 6 is negative 2. Do we need any more substitution examples? elimination. The goal with elimination is to be able to add our equations together and get variables to cancel. The only way that happens is if they are the same but opposite coefficients. So like 3 and negative 3, 5 and negative 5. Typically, you have to start out multiplying one of the equations by something for that to cancel. So if I wanted to cancel my x, what would I multiply the top one by? Actually just 2, since that's already a negative 4. If I wanted to cancel my y, what would I multiply by? Negative 6. Alright, so then I have 4x plus 2y equals 10. Negative 4x plus 6y equals 12. When I add, positive and negative 4x cancel. So I get 8y equals 22. Divide. And that gives me 11 fourths. Okay, everything is not going to be nice and pretty, so don't be alarmed if you get a fraction. I do want a fraction over a decimal. We want exact answers. So then, to get my x, I can plug that back in anywhere. Maybe I put it in for the second one. Well, I'll just go with the first one. It's pretty easy. So 2x plus 11 fourths equals 5. Okay, if I subtract over my 11 fourths, get 9 fourths, divide by 2, and we get 9 eighths. So my answer, 9 eighths, 11 fourths. Can you guys try one of these, do you think? Any questions about what I did here? Here is your problem too. Actually, not that one. I want you guys to do this one. So if you wanted to cancel x, you would have to get a 15 and a negative 15. So you could take, maybe this one times negative 5 and that one times 3. If you wanted to cancel y's, you would have to multiply the top one by 2 and the bottom one by 3. It doesn't matter. You'll get the same answer at the end. If I do this. Okay, negative 15 plus 15 is 0. 30 plus 12 is 42y. Plus 7 equals 0. So 42y equals negative 7, and y is negative 1/6. So then we plug that back in. I'll just go with the first equation. Okay, negative 6 times negative 1/6 is positive 1. So we get x to be 1/3. All right. How do you guys feel about substitution and elimination? Good? I want to do 2 last problems and just look at a couple special cases, and then I am done. All right. If I asked you to solve this one, what would you do? Okay. So I get a negative 4x minus 2y equals negative 10. Negative 4x plus 4x is 0. Negative 2y plus 2y is 0. So I get 0 equals negative 10 plus 8 is negative 2. What does that mean? No solution. So my actual answer is no solution. When I give you any of these, it will say solve. If the system is inconsistent, say so. Anytime anytime you get no solution, you are going to have to tell me this is an inconsistent system. Okay, so that means these lines were parallel, they never met. No solution is my answer. The type of system is inconsistent. And that happens anytime all of your variables cancel and you're left with a false statement. What if I gave you this one? So if I want to cancel x, first of all, to get rid of the fraction, I have to multiply by 3, right? And then I need it to be a 6, so 3 times 6 is 18. So I'm going to multiply an 18 through. So then I get 6x plus 3y equals 12. My second equation didn't change. When I add 6x and negative 6x is 0. 3y negative 3y equals 0. 12 plus negative 12 is 0. What does that mean?
Consistent solution.
It is consistent. We have solutions. But that means it's infinite solutions, right? All real numbers. Now, here is the one thing that we are doing differently than what you did last year. Before, you just said infinite solutions or all real numbers and went on with your day, right? But is it true that I can put any ordered pair in here that I want? No, it has to be an ordered pair on the line. Okay, so we are going to be asked to describe that. So you will see a statement like this. It says, if there are infinite solutions, write the solution set with either x or y arbitrary. That means I'm trying to describe the ordered pairs. If y is arbitrary, y is the variable that I keep. That means I need to describe my x's. Is everybody with me right here? So I'm going to take one of these equations, I'll just go with the second one, and I'm going to solve for x. Add over my 3y. Divide everything by negative 6. So x is negative 2 minus 1/2 y. That's what I'm going to put here. So it describes my ordered pairs. If I had said x arbitrary, then you would keep x. You would take one of the equations and solve for your y and put it in there. So that is really the only new piece today. Are there any questions about how I got that ordered pair? Okay. So there's a Math Excel assignment open. You guys should have enough time that you can get that done. I will also hand back your test.